As night settles and the house grows quiet, you've found a small, gentle corner where the universe speaks in a softer voice. Here, curiosity does not hurry. It wanders like starlight across a calm sky. Tonight, we keep company with the darkest question in astronomy. What waits on the other side of a black hole? We will sit by the event horizon as if at the edge of a moonlit lake, noticing how light bends, how time stretches, and how a hidden shore might exist beyond that dark boundary. No rush, no noise, only a slow unfolding of ideas meant to soothe while they spark a quiet sense of wonder. If this kind of stargazing keeps you good company, a light tap on like and subscribe helps other night listeners find their way here as well. It is a small gesture that opens the door for the next traveler. So we will begin, steady and soft, following the faint clues that physics offers and the questions that have lingered for a lifetime. The sky is wide, the room is still, and the story of black holes is ready to be told. How much do you truly know about black holes? What would it be like to fall toward one? Not as a stunt, but as a quiet traveler drifting through a deep night. Imagine you are out among dim stars, searching patiently for new ground for human feet, when a circular darkness appears where the sky should be bright. Curiosity speaks softly. You ease the nose of your craft toward the mystery and wonder what waits if you keep going. Is there any chance of survival? Is there a way back out? Could there be a shortcut to somewhere else? Perhaps a different universe wearing different rules? Despite the name, a black hole is not an empty hole. It is matter gathered so tightly that space and time lean inward, with no path out once you cross a certain line. Einstein's relativity predicted the recipe. A massive star burns through its fuel and can no longer hold itself up. Its core, the hot heart left behind, collapses. If that remnant holds at least about 3 suns worth of mass, gravity overwhelms every other force that tries to resist. The result is a black hole, not a gap in the world, but a knot of gravity that nothing can climb. To feel the scale without numbers, picture the sun's pull, already far stronger than Earth's. Now imagine forcing several suns worth of mass into a sphere small enough to sit inside a town. The weight would not just grow, it would deepen space itself, like pressing a heavy stone into a torch sheet and watching the surface gather around the imprint. Light that skims past such a place would bend. Light that tries to rise from inside would not return at all. You cannot see a black hole directly because it does not let light escape, yet the world around it tells on it. Gas falling inward heats and shines in X-rays before it disappears. Stars nearby move on, odd, fast orbits that only a great dark mass can explain. We have even imaged a black hole's shadow against glowing matter, a ring of fire with a round absence at the center. There is also a quieter prediction that belongs to quantum physics, living on the rim of gravity. A black hole should emit an exceedingly faint glow called Hawking radiation, a kind of slow leakage of energy from the horizon itself. For black holes born from stars, that glow is so weak, we have not yet seen it. But the idea remains one of the ways modern physics ties quantum rules to curved space-time. People have wondered whether such objects could be passages, not tombs. Stephen Hawking and others played carefully with the thought that under the most extreme conditions, a black hole might connect to a different region of space-time, maybe even a different universe. It is speculation, not a map, but it keeps the imagination company when the night is long. Every black hole is stitched by a boundary called the event horizon, the place where gravity's pull becomes a one-way slope. From outside that line, the sky looks distorted. Starlight smears into a bright ring around a perfect circle of night. Cross that line, and the path leads inward, as surely as time leads forward in an ordinary day. Falling begins gently and then gathers itself. Gravity pulls harder the closer you come. If you fall feet first, the pull on your feet is not exactly the pull on your head. For a small, dense black hole, that difference grows quickly and can stretch a body long before the horizon is even reached. The word sounds playful, yet the reality is stern. Spaghettification, a pulling apart that lengthens and thins anything not built of pure math. Stellar black holes, formed from single stars, are only tens of kilometers across, yet can weigh many suns. Near them, tides are sharp. Cross their neighborhood carelessly and you will be torn before you ever touch the horizon. Scale up the mass to the kind found in galactic centers, and the story softens for a while. A supermassive black hole, millions of suns in one dark place, spreads its pull over a larger region. At the horizon of such a giant, the difference in gravity between head and feet can be small enough that you would pass through intact, unaware of the line you crossed until deeper tides make their claim. There is one of these giants nearby on the scale of galaxies, settled at the heart of the Milky Way. Astronomers track stars wheeling quickly in tight loops around a point that gives off almost no light. That hidden mass is our central black hole. It is very far from the Sun, much farther than any wandering planet or comet, and it poses no threat to our quiet orbits. It merely waits at the center, a dark anchor for a bright spiral of stars. Do not pack a bag. If you aim for such a horizon and drift across it, the hardest part is not behind you. Deep within, every path narrows toward a center called a singularity, a place where our equations predict densities without limit and the known rules falter. You would be carried toward that center as surely as a leaf is carried toward a drain, and the procession would end with your matter added to the whole. No message would rise out carrying your account of the journey. The horizon keeps its secrets. For those who remain outside, time paints a different picture. As you fall, your signals climb out through heavier and heavier gravity. They stretch to redder colors. Your motions appear to slow. You seem to dim and pause, hovering just above the horizon, never quite crossing from the outside perspective. This is not a trick of film. It is the way time bends near such weight. Your clock continues to tick in order. Theirs runs differently, and so the two stories diverge without a lie told by either one. Inside, the geometry turns strange. The direction that once felt like a way becomes a direction in time. The direction that once felt like later becomes a place you cannot avoid moving into. Another way to say it, gently, is that at the horizon the roles of space and time begin to trade duties in the equations. Turning around becomes as impossible as traveling to last year. The choice to head inward is no longer a choice at all. What becomes of the story long after you are gone? In the slowest of clocks, a black hole can evaporate. With that faint quantum glow, energy leaks away and the hole shrinks. Eons upon eons later, it may fade to nothing, leaving only a cloud of particles spread thinly through space. Could anyone then point to one particle and say, "That was you"? The puzzle is called the information paradox. If the laws of physics do not like to lose information, where did the details go? Hawking first argued that they were lost, then later joined others in believing that subtle correlations could preserve them, perhaps encoded on the horizon as it radiates, perhaps written in ways we have not yet learned to read. The idea that information is stored on a surface rather than in a volume grew into what many call holography, a hint that the world may keep its books in elegant, unexpected ledgers. some thinkers reach for a different comfort. If the world allows branching histories in the deep sense suggested by quantum mechanics, a fall into a black hole might mean that in one branch you are gone, and in another the path carried you safely elsewhere. In that reading, the universe does not erase, it proliferates. Your friends in this branch never hear from you again. In a neighboring branch, a different story unfolds. It is an idea best held lightly, a way to keep wonder company rather than a ticket you can buy. The night around a black hole is not empty. It is full of rules that stay true whether you are near your front porch or passing a horizon. Mass bends space-time. Light follows those bends. Clocks keep honest time, but each keeps time for its own path. In the gentler gravity of your room, this knowledge can be a kind of lullaby. The universe is consistent enough to let you sleep. If you ever find yourself, even in imagination, floating before that perfect circle of darkness with a bright ring around it, you can trust a few things. Outside the ring, the stars continue their quiet courses. Inside, the path leads inward. From far away, the fall looks like a slow fade. From your seat, the crossing is ordinary until it is not, and then the center arrives. Whether black holes hide doorways or keep only their own counsel remains a question for mornings and chalkboards. For tonight, it is enough to know that such places exist, that our sky holds them, and that our minds can rest on the edge of the mystery without falling in. And if a thought lingers at the rim of that circle, it is the old, restless one. What if we went closer, not alone but with a whole world in tow? The mind asks dramatic questions in a whisper. Could such a thing devour everything we know? There are many out there, millions of remnants from ancient stars, quiet as stones, until something wanders too near. If a black hole ever strayed close, or if we were careless enough to invite one nearer, what would we actually see? And what, if anything, could be saved? The first picture to hold is gentle and honest at once. Most black holes are the ashes of massive suns, the stellar kind, as small across as a city yet heavy with the weight of many stars. They are common as fossils in a galaxy like ours, born when giants burn out and cave in. Far rarer are the giants at galactic centers, supermassive black holes with diameters on the scale of our whole solar system and masses stacked by the million. One of those sits deep in the Milky Way's heart. Sagittarius A*, patient and remote, an anchor for our spiral rather than a hunter in our neighborhood. Danger is not a simple question of size. It is a question of distance. A speck with extraordinary density, drifting uncomfortably close, could tug air from our skies and tides from our seas. A giant far away is only a point of curiosity in a telescope. The horizon, the border where escape becomes impossible, draws the cleanest line, and the pull grows wilder long before that line, especially for small black holes, where gravity's change over short distances is severe. Near such a place, the side of Earth nearest the hole would feel more force than the far side. The planet would begin to stretch toward the dark, as if the whole world were a tide. If the approach were direct, the story would be brief and unkind. Our upper air would fray and stream away. Then rocks would join it. First dust and mountains, then plates and oceans, torn free in great sheets. Strands of matter would wrap into a bright, thin river spiraling inward, glowing as it fell. From afar, you would see a flattened ring of heated debris brighten around the darkness, a crown of light fed by our own scattered stone. Capture without immediate plunge has its own cost. Should Earth fall into a tight orbit around a black hole, The uneven pull would knead the planet over and over, a process called tidal heating. The crust would groan and shift, the mantle would warm, the core would churn. Earthquakes would grow constant and deep, volcanoes would find new mouths, tsunamis would trace long lines across the basins. A world can endure much, but relentless kneading from such a neighbor turns continents and seas into instruments for a harsh music no life can dance to. The word spaghettification sounds light, but it names what happens when gravity's difference between head and foot becomes a stretch. People feel it in stories, planets feel it in truth. For a small, dense black hole, this thinning can begin well outside the horizon, pulling a body into a long thread before it ever reaches the border. For a supermassive one, the same shredding would happen deeper in, past the horizon, because the gradient of gravity at the edge is gentler. Either way, the ending is the same. Matter unravels. Rocks become dust. Dust becomes plasma. Atoms line up like notes on a staff, and then blur. A whole solar system pulled into such a story would not hold its old geometry. The careful balance we live inside, sun and planets trading, pulls that line up into stable years, would collapse under the newcomer's influence. Worlds would be nudged toward one another into crossing paths. Some would be flung outward into night, others would fall. The belt of asteroids between Mars and Jupiter, quiet most days, would be stirred. Many are small, a few are huge. A single large strike is enough to change everything long before any horizon is reached. Even if scattered survivors clung to fragments for a time, the environment near a feeding black hole is not a refuge. Material falling in does not slip silently. Friction heats it. Magnetic fields whip it. Radiation grows fierce. Some of that energy spills outward in jets and winds. Life huddled on rock would be soaked by light that burns without flame. In such a furnace, the idea of waiting it out becomes a kind of wishful poetry rather than a plan. There are softer arrangements we can imagine because the sky has already shown cousins to them. Astronomers have found worlds that orbit two suns, circumbinary planets that split their year between twin dawns. Could a planet share a long dance with both a star and a black hole? The mathematics does not forbid a temporary balance, especially at distances where the black hole's pull is steady and tides do not tear. Yet habitability is another story. The same forces that make the orbit interesting would make the world restless. Heat would well from within, and small perturbations could send the planet out of its lane or into the arms of one partner or the other. It is an image to contemplate, not a place to send a garden. The black holes that concern us most are not necessarily the brightest. Many announce themselves by how greedily they feed, drawing gas from a companion star, lighting the neighborhood with X-rays as the flow heats. Others hide in plain darkness and give themselves away only by their effects on nearby objects. One of these quiet neighbors was noticed not long ago and given a name that sounds almost friendly: Gaia BH1. It is not right outside our door, yet it is closer than most, on the order of a couple of thousand light years, tucked into our region of the galaxy. It does not glow or feed in a way that catches the eye. Astronomers found it because a nearby star wobbled in a way only an unseen heavy companion could cause. The pair circle together, one bright, one dark, a reminder that invisibility is not the same as absence. Hearing that there may be 100 million stellar black holes scattered through the Milky Way could make the night feel crowded, yet scale comes to the rescue. Space is generous with distance. The ones we have catalogued are, for the most part, far-flung and unthreatening. The nearest candidate systems are quiet, even at their modest remove. Our sun and its family are not likely to be jostled by any wandering heavyweight in the lifetimes of species, much less of single lives. Catastrophe is a loud idea. Reality, in this case, is mostly silence. Still, imagining the hard path is a way of appreciating the soft one. Knowing that a black hole's horizon is a point of no return sharpens what far means. Recognizing that a tiny, dense intruder near our orbit could make tides out of continents teaches you to love the ordinary gentleness of the moon's pull. Understanding that the glow of an accretion disk is the light of things being unmade lets you look at the dim band of the Milky Way with kinder eyes. We are lucky to be far from maelstroms and close to a star that keeps time. If you step back to the window where we left the ring of light and the circle of dark, the story settles into its earlier rhythm. Outside that ring, stars keep their appointments. Inside, paths narrow. Between those truths lies the rest of our understanding. Tidal forces that can knead a planet, horizons that divide can from cannot, quiet neighbors detected by subtle wobbles, great anchors at galactic centers that mean us no harm. Even the numbers you could memorize are less important than the feeling they give you. A universe that is dangerous in places and enormous enough to offer safe harbors. So the answer to the late-night question is simple and sufficient. Could a black hole take everything? Only if one comes implausibly close, and the sky's current ledger shows no such approach. Could Earth split its days between our sun and a dark partner? Perhaps for a while, but not as a home for life. Would we survive the long stretch and the bright ring of falling matter? No, not as bodies. As stories, perhaps. As understanding, certainly. And in the meantime, our world turns under smaller tides. Our auroras speak in green and violet rather than in X-rays. And we can rest with the knowledge that these dark engines exist, that we have learned to name them, and that the night is wide enough to hold both awe and ease. The night can hold both comfort and curiosity at once. So after answering the anxious question, the mind drifts to stranger shores. If most black holes are distant and our own sky is calm, are there others out there so peculiar they bend not just light, but our expectations? Astronomers sometimes meet such puzzles first, as rumors in the data, small wobbles and dim signatures that suggest something impossible, and then ask for patience. One such rumor wore a musical name, LB1. At first glance, it seemed to be a black hole in the Milky Way with a mass far beyond what ordinary stellar deaths should make, too heavy to be one of the common stellar kind and far too small to be a central giant. For a time, the community held its breath. If true, it would widen the starry recipe book in a dramatic way. Before LB1, the categories felt tidy enough to use as a night's compass. Stellar black holes are the compact remnants of massive stars, scattered through galaxies like fossils. There may be hundreds of millions of them in our spiral home alone, most weighing roughly a few tens of suns. Supermassive black holes sit like anchors in galactic hearts, their masses rising to millions and billions of suns, their horizons on the scale of solar systems, their origins still the subject of careful debate. Between these two families lies a long, dark stretch with few confirmed residents. LB1 seemed to camp in that gap. Reports spoke of a mass around 70 suns, awkwardly large for the usual stellar story, yet laughably small compared with central giants. Explanations blossomed. Perhaps we were seeing two lesser black holes circling each other. Perhaps it was a newborn heavy remnant not yet settled. The answer, as it turned out, was kinder to our existing maps. LB1 was not a black hole at all, but a rare dance of two unusual stars, whose light and motions conspired to mimic the presence of a hidden weight. The mirage dissolved, and our understanding remained intact. No scolding was needed. Studying a faint system 15,000 light-years away is like reading a postage stamp across a river at dusk. Errors are old friends in that kind of work, and corrections are simply part of the conversation. That calm correction does not lessen the wonder black holes deserve. The quiet giant at our own galactic center, Sagittarius A*, weighs in at about 4 million suns and rules its neighborhood with a gentle hand. We have watched stars near it trace tight, swift loops as if they were beads sliding along invisible wires. For all its mass, it sits far away, and our days go on untroubled. Elsewhere, the scale climbs to something that feels almost mythical. The black hole known as TON 618 lives in a bright, distant quasar, a lighthouse from 10 billion light-years away. Its mass is often estimated at tens of billions of suns, and the light from the matter it is consuming outshines its host galaxy by a staggering margin. To hear such numbers is to feel language thin, yet the images carry a steady truth. Gravity, given enough fuel and time, can build an engine that glows like a small universe. When numbers stretch, names sometimes follow. Astronomers have joked and then half-adopted a label for the truly extreme cases: stupendously large black holes. One candidate for that oversized nickname sits in the galaxy cluster known as Phoenix. The central black hole there is estimated to tip the scales near 100 billion suns. Its event horizon would be so wide that measuring it in ordinary terms feels like counting with seashells. Imagine a diameter roughly 100 times the distance from the Sun to Pluto. A ship coasting at familiar human speeds would spend centuries just crossing its shadow. Fortunately, the Phoenix cluster is billions of light-years away. A distant furnace that warms us only with ideas, closer to home in the map-making sense. Astronomers have begun to spot pairs of supermassive black holes bound to one another. Two dark hearts in a single galactic body. One such pair lies a few 100 million light-years away, a near neighbor on the scale of the cosmos. They will not marry quickly. For eons, they will spiral inward, flinging energy into space as they dance, their steps writing ripples into the fabric of space-time. The waves from a union like that are deep and long, a background hum the right instruments can learn to hear. We have already started to sense this cosmic music as a low, pervasive chorus, and in time the song of individual pairs may be heard clearly. Those ripples bring us to a question that sits even closer to the heart. Our Milky Way and the Andromeda Galaxy are moving toward each other at a stately pace, and in billions of years they will blend their stars and dust into a single new system. What then for the giants at their centers? The likeliest answer is steady and grand. The two black holes will find each other amidst the mixing, shed their orbital energy to surrounding stars and gas, and settle into a long spiral that ends in a merger. The final moments would ring the cosmos with waves strong enough to be felt across vast distances by observatories built for that far future. To any quiet shore where life might be listening, the universe would briefly thrum like a plucked string. Between the extremes, the story stays modest. Most so-called monsters are simply far away. A few masquerade as something else until better measurements clear the fog. A handful blaze so brightly that we can see them across a large fraction of the visible universe. Each one, bright or quiet, adds a stitch to the same tapestry. Gravity gathers, matter falls, light struggles, and often fails to flee. Time itself leans. The details grow wild, but the melody remains reassuringly familiar. If these tales feel large, they are meant to be, yet they can still be held gently. The lesson tucked beneath the numbers and names is not that danger waits around every corner, but that the cosmos builds on repeating themes. A small black hole in a binary system and a stupendously large one in a distant cluster obey the same rules. Horizons scale, temperatures change, feeding patterns shift, but the grammar of space-time stays consistent. It is the kind of consistency that invites sleep rather than worry. You might picture the sky as a quiet porch with a far-off storm flashing now and then. Ton 618 lights a whole horizon the way distant heat lightning does. The Phoenix cluster holds a furnace too far away to burn your skin. Pairs of giants sway to a rhythm so slow that it marks epochs instead of evenings. Closer by Sagittarius A-time sits patient and reserved, a weight at the center that means us no harm. Even the almost was of LB1 becomes part of the comfort, a reminder that science keeps its cool, corrects itself, and moves on. When the mind returns to the image of the ring of light around a circle of night, the next breaths come easily. The ring may belong to a modest stellar remnant, to a million-sun anchor, or to a monster that could swallow a system whole without noticing. The circle at the center is always the same. The place where paths point inward, where stories about doorways and other universes can visit without proof, where the night grows thoughtful. Out here, under ordinary gravity and a friendly atmosphere, that image is enough. Black holes can be sailors' tales and measured facts at once, both lullaby and laboratory. The porch is still. The stars continue their quiet courses, and the knowledge that such extremes exist, kept at a safe remove by a generous universe, tucks itself around you like a blanket you have used for years. Holding that ring of light image a little longer, curiosity turns the coin over and wonders about its mirror. If a black hole is a place where paths lean inward, what would a perfect opposite look like? Some equations do allow a reflection called a white hole. Not a mouth that swallows, but a fountain that never lets anything fall in. It would behave like time-reversed gravity's maw, a source that throws matter and light outward rather than pulling them down. No telescope has confirmed such a thing, so it belongs to careful thought more than to maps. Yet the idea has been patient company for decades. Set the two side by side in the mind. One draws, the other casts. A black hole's signature is the quiet grip it keeps on everything that crosses the horizon. A white hole, in the purest picture, refuses entry at any speed and pours energy outward instead. Some researchers even play with the notion that a black hole, after an age and under quantum rules, might loosen and reappear as a white hole, a brief coda that returns what was gathered. In such sketches, the outflow would be fierce, material racing away at relativistic speed, and the fountain would be short-lived. Whether nature ever stages such a transformation is unknown, but the thought helps us feel the symmetry the mathematics invites. If such opposites met, the scene would be dramatic without needing noise. The white hole cannot accept a gift, it only expels. The black hole cannot refuse one, it only takes. Outflow aimed at a black hole would become food. The more the fountain pushes, the more grows. Nothing in this picture grants the fountain a trick that the maw cannot answer. Over long spans, the black hole would harvest the white hole's emission, swelling with every mouthful. The contest would not be a clash of equals, but a long, uneven exchange that ends when the fountain runs dry. In that imagined finish, the dark circle wins by simply continuing to be itself. A black hole that has fed well becomes a different kind of landmark. The one at the center of the galaxy, M87, the same object whose shadow we have imaged against a glowing ring, is tens of billions of kilometers across from rim to rim if you measure the horizon's diameter. Hold that width in mind and it feels like a small solar system carved out of light. A meeting between a fountain and a maw, if the fountain ever existed, could only make such a circle larger and harder to ignore. From that imagined encounter, the mind wanders to a more personal fable. What if the largest of these dark engines chose a long road that led, one day, through our neighborhood? The rules do not change for monsters. A black hole differs from other massive objects chiefly by what it does to paths near its horizon and by how tightly it packs its mass. At the heart of its description lies a point where the known equations give densities without limit, the singularity that serves as a warning that new physics may be needed. Outside that unreachable center, a black hole is a mass in space. Gravity is gravity. The pull strengthens with more mass and with less distance. Most black holes are made from stars gone quiet, and many of those weigh in at a few tens of suns. One sun already outweighs the Earth beyond easy imagining. A single solar mass is hundreds of thousands of Earths. The big ones at galactic centers tuck many millions or billions of suns into a volume whose edge we call the horizon. Some estimates and models allow for rarities that reach 100 billion suns, a class some astronomers, with a smile, have nicknamed stupendously large black holes. There is a famous bright one called TON 618 that shines as a quasar many billions of light years away and is commonly estimated to hold on the order of 60 billion suns. As light makes its slow journey from that distant time, we see the glow of matter falling in, a lighthouse that outshines its host galaxy. Imagine such a giant steering our way. The journey would be measured in ages. Distances of 10 billion light years are not crossed in a hurry. Along that long route, the black hole would not travel like a broom. It would pass through regions where gas and dust have pooled, and there it would feed. Stars unlucky enough to wander close would be unmade, their long fusions ended in tides and heat. The glow from an active feast is not subtle. Long before any approach to the Milky Way, observatories would notice an upwelling of radiation across many wavelengths, a beacon that grows brighter as the distance dwindles. Near the edge of our spiral home, the first things to feel the newcomer's presence would not be people or planets. The Orion Arm, the spiral lane where our sun happens to reside, stretches for tens of thousands of light years through a field of gas, dust, and stars. A massive intruder would stir that lane like a slow spoon, warping orbits, igniting fresh bursts of star formation in some places, stripping and scattering in others. The neat geometry seen in textbooks would blur into a different, more chaotic beauty. Far outside the planets lies a vast and faint sphere of icy debris called the Oort cloud. It bounds our system the way fog sometimes bounds a field, thin and wide. An approaching giant would pluck at that sphere, sending many small bodies inward on long, cold arcs. The Kuiper Belt, a nearer ring beyond Neptune filled with ancient ice and rock, would also be churned. Comets would bloom as they heated, and many would race sunward, some past us, some into us, a slow storm that lasts longer than a civilization. Closer in, the planets would face the simple arithmetic of tides. The ice giants on the far edge would falter first, their orbits altered, their atmospheres teased into tails. The big gas worlds would fare no better if the intruder came close enough. Saturn's rings would become a temporary signpost, and then debris. Jupiter, mighty as it seems to us, would be pulled into strands if it crossed the wrong threshold. Mars, our red neighbor that many dream of visiting, would become another line in the geometry of falling. None of this requires the horizon to arrive. Steep gradients in gravity can unravel worlds at distances that still feel far on human scales. For Earth, there are two endings in this tale. In the better one, the intruder grazes the outskirts of the solar system and passes on, leaving scars in the form of altered orbits, heavy impacts, and long winters. The world we know is bruised but persists. In the harsher version, the path takes the black hole close enough that our planet is drawn toward the point of no return. As that line nears, the difference in pull between the side facing the black hole and the side turned away grows severe. A sphere becomes a lengthening strand. Spaghettification is the word, whimsical to the ear and precise in its meaning. Rocks, then minerals, then molecules are pulled into alignment. Within a short stretch of time, the world that held seas and forests becomes a filament of matter glowing as it falls, a last bright line that vanishes into dark. The sun would not stand apart forever. If the intruder stayed and the dance of gravity demanded it, our star would be next. A star fed to a giant black hole becomes a flare and a memory. The glow of the accretion flow spikes. The horizon fattens. For a while, the location where our solar system once turned would be occupied by an absence edged by violent light. The radius of that horizon could reach into the inner regions of the former Oort cloud, an emptiness stretched across a span that used to hold family. Black holes do not linger without company forever. A traveler of this size moving through the Milky Way would, given time, feel the tug of the central mass and the geometry of the galaxy as a whole. The path would bend toward the heart, where Sagittarius A time sits. Two giants brought together do not collide like stones. They circle, shed energy to their surroundings, and gradually commit to a union. In the final moments, they stir space-time in a way that sends waves outward, ripples that swell and fade and can be measured far away by instruments that listen for such events. We already hear a general murmur from many supermassive pairs humming together across the sky, a low chorus that confirms the dance is common. The habit of the universe is to show us old things still burning. J2157 is a quasar lit by a black hole that tips the scales at tens of billions of suns. It eats starlight for breakfast in the sense that gas and dust falling in release more energy than a simple torch. And it does so from an age not long after the first galaxies assembled. If a creature like J2157 ever wandered into our era and our neighborhood, the same quiet arithmetic would apply. Gravity would write the plan. Orbits would become ovals and then lines. Heat would rise where cold had slept. Days would narrow into minutes as horizons drew close. The speed with which such a story finishes depends on distance and approach, not on appetite alone. You do not need to carry the harsher endings into sleep. The probabilities are not waiting at the door. Systems like TON 618 and the Bright Engine in J2157 live in remote quarters. Their light is old when it reaches us, and their paths are written among faraway structures. Our own galaxy has its central anchor and the usual scatter of stellar remnants. The nearest confirmed black holes are many light years away and quiet. The sky is not empty of hazards, yet it is generous with space and time. What remains after a walk through these imaginings is a sense of scale and a respect for the rules that keep their promises. White holes make a good mirror for thought, even if they never appear in a telescope. Black holes grow by doing what they always do, and even their largest versions obey the same paragraphs of physics as the small ones. Mergers are slow and stately by our standards, and when they happen, they sing in waves we can learn to hear. A spiral arm is long enough to be a pathway for a traveler that no ship could outrun, yet it is also wide enough to cradle a quiet star with quiet planets for billions of gentle orbits. Return again to that ring around the circle. The night has not changed. The porch is still. If your mind wants more, it can wander to fountains that never accept a cup and mouths that never spit. To giants so large their edges are measured in thousands of times the space between Sun and Pluto. To beacons that shine so fiercely they outglow their galaxies. To pairs that circle and sing. If your shoulders want rest, they can accept another truth at the same time. For us, here and now, the dangerous places are far. We know their names. We have weighed some, photographed the shadows of others, and traced the trembling of stars that move in their grip. Knowledge does not remove mystery. It makes a wider, kinder room for it. So the blanket can be pulled a little higher. The image at the center of the story remains simple enough to hold while sleep comes. A circle of night where light goes in and does not return. Around it, a ring that changes as matter falls. Above the house, a sky that keeps its roots. In between, a mind that drifts, content to stand at the edge of the deep and listen without fear. Let the circle of night and its thin ring of light rest on the mind a moment longer, then tilt it toward a homely question. What if that dark geometry ever reached for our own small hearth? What if the sun itself met such a visitor and the sky we know changed its habits? The thought is not a summons to worry, only a lantern we carry as we walk a little farther into the story. A black hole is born from a life that burned hot and ended quickly. A massive star exhausts its fuel, loses the pressure that held it up, and folds into itself until the matter is packed so tightly that even light cannot find a path out. The smaller kind, by cosmic standards, the stellar remnants, can be only a handful of miles across and yet carry the mass of many suns. Their density makes their gravity steep, and that steepness is what turns a person or a planet into a stretched thread if they stray too near. Beyond the horizon that marks the point of no return, every path aims inward. The stretching that storytellers call spaghettification is not a joke there. Head and feet feel different pulls. Rock and metal align like fibers, and the fall proceeds without drama toward the center we cannot see. Other black holes do not fit in the mind so easily. Far from the calm neighborhoods where ordinary stars live, supermassive black holes anchor galaxies. Their horizons can reach the scale of our solar system, their masses counted in millions and billions of suns. They do not form from single stars, and their early growth is still a living research question. But once they exist, they tend to sit at the heart of things and feed when gas flows in. Among these giants, one shows up in the ledgers with a name that sounds more like a catalog entry than a roar. Astronomers call it J2157. It has been measured as one of the fastest growing and most massive known, and the edge of its no-return region would sit far beyond the orbit of Neptune if centered on our Sunday. In the language of distances we use for planets, that horizon stretches hundreds of times farther than the line that marks Neptune's path. The accretion disk around such a creature, the ring of infalling matter that heats as it spirals down, shines with a light fierce enough to outglow stars nearby. In studies of its appetite, J2000 157, has sometimes been described as consuming on the order of a sun in a day, a number that tells you more about the scale of the engine than about any taste for drama. Bring an engine like that anywhere near our home, and the sky would change its color. The bright disk around the black hole would paint the night with a steady, unnerving glow, brighter than familiar phases of the moon, a lantern that outshines most stars. Even without an immediate embrace, the radiation from such a disk would harden the daylight and complicate the chemistry of air and skin. It is a comfort to remember that J 2157 does not keep us company. It lives in a distant past, billions of light years away, its light sent toward us when the universe was young. No path drawn by a quiet porch in this century intersects its road. Meeting a smaller intruder would write a different script, no less stern. A black hole under 100 million suns would not swallow our star in a single bite. The sun would bulge, streamers would form, and the star's outer layers would begin to peel away, gas pouring into a spiral that glowed as it fell. The core would be left ragged, a cloud of hot hydrogen and helium unspooling. The radiation from that process would reach Earth like weather we have never known. The magnetosphere would complain. The upper air would heat and change. Electronics and biology alike would notice. In time, the star we love would dwindle. In the harsher version of the tale, an even heavier visitor ends the sun in a short, catastrophic swallow. Not a season's unraveling, but a gulp. For Earth, there is no kind ending once the sun is taken. Tides from the intruder could pull the planet apart even before any horizon is met, turning continents into finds and oceans into tails. If the orbit took us deeper, the radiation from the accretion flow would bathe us beyond endurance. In the last steps, our path would cross the boundary and time itself would feel as if it were leaning, space turning forward, and the world that held gardens and songs would become a filament, glowing as it fell into black. Reassurance returns with the map. J 2157 sits a long way off, a number with many zeros that reads like a fairy tale. The other giants that haunt catalog pages keep their distance as well. The nearest black holes that astronomers can point to with confidence are quiet and far, and the sky between stars is so vast that simple proximity protects us better than shield or wall. The universe is dangerous in places and generous with space. The mind that has walked that dark path often wants to step back into the brighter rooms of human craft, as if to test whether our own machines could ever invite such engines indoors. On the border between France and Switzerland, there is a ring of magnets under the fields that hums gently when active. The Large Hadron Collider sends particles racing around that ring, almost but not quite at light speed, and lets them meet in tiny, precise collisions. The point is not destruction, but revelation. New particles appear in the debris that tell us how the world is stitched, and some of these often carry names that once belonged to ideas and are now chalk marks removed and rewritten as facts. A question that has visited more than one dinner table is whether a machine like that could make a black hole. The short answer is that it could, in principle, but not one you could see or touch. The energies in those collisions are large by human standards and tiny by cosmic ones. If a micro black hole flickered into existence inside the detectors, it would be smaller than small, so light in mass that it would not reach out and take anything with it, and so short-lived that it would evaporate almost at once. The whisper of a black hole that size would be a handful of exotic particles and then silence. The reason is a quantum rule that returns to us here under a name we used earlier. Hawking radiation allows tiny black holes to shed energy. The smaller they are, the faster they vanish. A micro hole made in a collider would be gone before it had time to beg for a crumb. Even imagining a larger laboratory in the future does not invite a different ending. Engineers sketch a wider ring called the Future Circular Collider, a sweep that would outdo the current machine. The questions it might answer are clear and tempting. The risks stay small. To make a black hole with enough mass to resist instant evaporation in a way that matters to us, you would need to gather more mass than any particle machine can dream of putting into a single point. Consider a threshold so modest in human terms that it fits on a fingertip, a fraction of a gram, and then recall that it would take absurd, age-long spans for such a seed to grow by eating anything at all. Even the most playful back of the envelope arithmetic says that the time needed for a hypothetical lab-born black hole to reach the weight of a paperclip would stretch longer than the age of the universe by a margin that makes the whole idea melt into laughter. There is a reason to keep the numbers on the far side of the window and let the mood stay calm. Our world does not end when physicists turn a key. The Earth is not devoured every time a beam is steered into a target. The machines that frighten when described quickly are instruments of clarity, not engines of doom. They study particles that have already been colliding in the upper atmosphere for billions of years, thrown there by cosmic rays with energies beyond anything we can produce on the ground. If those ancient natural collisions did not end the story, the quieter, controlled ones in a ring of magnets under farm fields will not either. So the imagined visit from a hungry giant returns to the shelf where we keep unlikely things. The sun continues to write its patient letters in light. The planets keep their appointments. A ring road under a meadow hums now and then, and a chalkboard gains new lines, while another child learns the names of the seasons. None of this denies the presence of dark engines in the map. It says only that the map is large, and our dot is small, and the distances between dots are friendly to sleepers. If the mind wants a last picture to take into the quiet, let it be a small one. Not a horizon wide as 100 Neptunes, not a disk that outshines a sky, not a ring of magnets under a border, but the steady warmth of a star that is not being eaten today. Somewhere during the night, a particle halfway across the universe will fall into a black hole and add the faintest possible heat to a disk that shines like a second galaxy. Somewhere else, a scientist will compare two curves on a screen and decide that a bump is only noise and go home. Here, the porch is still. The circle of night in the mind keeps its shape. The ring around it glows, then dims, then glows again as thoughts turn, and sleep, which is its own kind of horizon, arrives without any need for calculations at all. With that small picture warming the mind, another thought arrives and settles beside it, not to alarm, only to satisfy a quiet curiosity. Stories sometimes say that getting too close to a black hole opens a shortcut to a parallel world or tips you gently into tomorrow. The real sky is less theatrical. A world that strays too near does not step sideways into another timeline. It begins to come apart, first in its breath. The highest air thins and streams away. Then the lower air follows, and soon rock and water feel the same pull. The change is not a door opening. It is a thread unspooling. Shift the scene a little farther out, where it is possible to think instead of flinching. Suppose a black hole appears in our neighborhood without brushing Earth, and we have room to watch. Place it in the middle of everything we know and let the clock run. The first, gentler version keeps the sun and adds a black hole with the sun's own mass. Two heavy partners would circle a common center only a fraction of the Earth-Sun distance apart. To the planets, the combined pull would feel like a single anchor with roughly twice the sun's mass. Orbits would have to quicken to stay aloft. A year on Earth would shorten, not by a sliver, but by enough that calendars would need new shoes. Something like 258 days instead of 365. As the sun moved around its dark partner, our distance from the sun would breathe in and out, and so would the light reaching the ground. Seasons would be shuffled and stretched. Yet day would still follow night. Gardens would still wake with spring, and the quiet habits of life could, in principle, adjust. The second version removes the sun altogether and replaces it with a black hole of the same mass. Gravity would remain familiar at the distances where planets travel. What would vanish is light. Earth would be carried around an object that shines only in the company of falling matter. The ground would not freeze in an instant. Our atmosphere buffers change, and the greenhouse effect buys time. For a few days, the average warmth would hover near freezing. By the end of the first year, it would sink well below, toward the kind of cold that ends rivers and hardens seas. Photosynthesis would falter almost at once. Small plants would fail first, then larger ones, then the animals that depend on them, and the animals that depend on those. The food web is sturdy when fed and brittle when starved. There is a speculative lantern that some physicists like to hold up in this darkness. The universe is filled with a faint, ancient glow called the cosmic microwave background. The last light of the Big Bang now stretched to long, cool wavelengths. A very rapidly spinning black hole could, in theory, twist that background light toward shorter wavelengths for specific paths near the hole, redirecting it into beams of usable brightness. It is an idea to be handled with care, more thought experiment than engineering plan. Yet, it shows how the fabric of space-time can, on paper, trade motion for light. The price is severe. Orbits that skim such a machine without being dragged inward would need to fly almost as fast as light. Years would contract to heartbeats. The least mistake would be a fall, and any real stream of meteors or dust feeding the hole would flash into radiation that could strip the air from a world like ours. A beam of borrowed daylight is not much comfort if the cost is to live beside a furnace. Set down the lantern and return to the question of paths. Even without swapping in new centers, there is another way for a black hole to trouble a system like ours. Not all black holes sit patiently at the hearts of galaxies. Collisions and close passes between galaxies can throw them from their nests. Some wander. In the observable universe, there may be staggering numbers of black holes. Many live in crowded centers like Sagittarius A times in the Milky Way. But a smaller share move almost alone, unlit and quiet until they meet gas. A handful may roam our galaxy. Most will never pass near anything that notices. A few will. If one happened to draw a line through our outskirts, the first sign would come from far beyond Pluto. Out there lies the Oort cloud, a deep freezer of comets and ice spread thinly across a sphere that reaches almost 2 light-years from the Sunday. A passing black hole would tug at that fog and send long arcs of ice inward. For years and then centuries, more comets would bloom tails as they warmed. The inner ring of ancient ice and rock beyond Neptune, the Kuiper Belt, would also feel the nudge. As the intruder drew closer, the ice giants would advertise its approach. Through a telescope, their atmospheres would grow ragged. Long curls of gas pulled away into a faint spiral. Those streams would heat as they fell and would collect into a disk around the visitor, a bright ring that makes the invisible visible. The same would happen to Saturn and Jupiter if the path came close enough. The giant planets are robust, but they are not immune to tides written by a heavier hand. The rocky inner worlds would be next. Mercury and Venus, then Mars and the Moon. Each would find their orbits pulled into new shapes. Some paths would cross. Collisions would be likely. Others would shrink until the line that marks no return cut them in two. From a backyard on Earth, the night sky would thin as familiar points vanished. It would not be a magic trick. It would be gravity keeping its promises. Earth would not be spared at the end of such a procession. The only difference would be timing. Spared is a word that belongs to other stories. If you follow that imagined visitor all the way in, a final act becomes visible. A black hole is not a ball in the old sense. It is a region where space-time tips toward a center that people call a singularity because the equations we use no longer know what to say there. Outside, gravity is gravity. Inside, time and space trade responsibilities. When two massive black holes find each other, they do not clap together like stones. They spiral, they shed energy to passing stars and to the gas they stir, and they write long ripples into space-time. Those ripples are called gravitational waves, and we have learned to hear them from smaller pairs of black holes and neutron stars. Pairs of giants sing in a lower register. Arrays of precise clocks have begun to catch that bass note, a background hum across the sky. If our visitor ever met the Milky Way's central black hole, the last few moments would ring loudly enough for distant listeners to notice. The union would leave a heavier, larger horizon where two once circled. Numbers drifted through this walk, and they can be set down gently again. There are estimates of how many black holes the universe may hold. There are guesses at how many wander in the Milky Way. There are models for how quickly a world cools when its star goes dark, and for how swiftly a year would pass around a doubled center. They are useful for keeping expectations honest. They are not meant to crowd sleep. What matters to the mood of the room is that the nearest giants are far, the local ones are quiet, and the fabric between stars is wide. If the mind still wants to test the edge of the map, it can think of a black hole that bears down on the sun itself. The meeting would not be subtle. The first touch would pull gas from our star into a bright stream. The halo around the visitor would blaze. Waves of radiation would say hello long before the horizon said goodbye. For a short while, Earth would live beneath a sky that burns on both sides. A dim sun crumbling and a bright disk gathering what falls. Then tides would tighten their grip. The inner planets would walk a last few steps in lines that narrow, and the rest is a softness of language for a hard fact. Worlds become threads. Threads become light. Light vanishes. And yet, between such tales and the actual night, there is a kindness built into space. The sun rises and sets because the distances are large and stable. A black hole with the hunger of J2157 lives, so far away that its light has been traveling toward us for most of cosmic time. The handful of black holes close enough to put names on are calm and too distant to disturb a quiet morning. The largest risks we court come from our own engines and our own choices, not from visitors out of the dark. So it is safe to keep the porch as the last image. A small star warms a familiar yard. Somewhere far away, a particle falls into a horizon and adds a whisper of heat to a disk that shines like another galaxy. Somewhere nearby, a researcher decides that a blip in a graph is only the hum of a power supply and turns off the lights. Here, the ring of light in the mind glows and dims as thoughts drift, and the circle in the center remains a calm idea rather than a nearby fate. If a black hole ever replaces the sun in a story, it will be a story. If one ever wanders past the Oort cloud, we will hear of it long before we feel it. Between those possibilities and this moment lies the generous distance that lets people sleep. Let the porch fade just a little, And in its place, imagine the sun from a quiet distance, steady as ever, until a new weight wanders near and the story grows strange. A black hole would not gulp our star in a single, flaming swallow. It would begin by unspooling it, thread by golden thread, the way a single tug can pull a yarn free from a ball. Loops of hot gas would lift from the sun, flare, and then fall into a broad, bright river around the visitor. That river is the accretion disk, fed not only by the sun's torn edges, but also by any dust and stray stone that happens to be in the path. The black circle at the center would still look like night, but the ring around it would blaze with warning light. The unwinding would continue until the familiar star was no longer a sphere at all, only a plume and then a cloud, the tail end of which might drift away, spared by distance or luck. From Earth, the news would arrive on light's schedule. For a few quiet minutes after the first pull, we would still see our ordinary sun, because even catastrophe must travel at the universe's limit. Then the sky would change. Bursts of harsh light, ultraviolet and X-rays would reach us, not as gentle warmth, but as a hard wind from the disk, where infalling gas sheds energy as heat. The black hole itself does not shine. The falling does. With the sun unmade, the balance we live inside would not simply tip, it would collapse and reassemble into something unfamiliar. Planets would seek new lanes under a different pull. Orbits would stretch, break, or knot into precarious ellipses. Tides from the intruder and from the shifting mass of what used to be our star would knead Earth in cruel rhythms. Faults would slip. Volcanoes would find new throats. Basins would lift and fall under long, heavy waves. In one ending, the world cracks and becomes a family of fragments. In another, the planet is flung outward, a dark wanderer without a sun, where cold has the last word. The best we can say, with strangely tender honesty, is that the garden would not survive as a garden. Such thoughts are best placed back on the shelf after being held a moment. They make room for a different kind of wondering, softer in tone and deeper in time. Not how a single world ends, but whether the universe itself could ever be erased. People sometimes say the universe is like a great computer, forever processing information. It is only an analogy, yet it points to something real. In physics, information is the full description of how things are arranged at their smallest scales. The pattern that makes diamond hard and graphite soft, even though both are woven from the same carbon. Energy is conserved. So, in our best quantum rules, is information. It can change form, hide, and scramble, but it should not simply vanish. Black holes press on that promise. They are the ultimate compactors. Anything that crosses the horizon is carried inward and, by the classical story, crushed into a point where our equations fall silent. What then of the information that once described a star, a rock, a person? If the horizon is a one-way door and the interior is mute, has the world lost a page from its ledger? This question is the heart of the information paradox. In the 1970 seconds, Stephen Hawking wrote a new chapter. Black holes, he showed, are not perfectly black. When quantum fields are considered near the horizon, pairs of particles can appear and leave behind a faint glow. Over a very long time, a black hole can leak energy and mass through this process and eventually evaporate away. The glow itself looks, in the first calculation, like featureless heat, pure temperature, no fine-grained details. If that were the whole story, the information that fell in would not be carried out again in any readable way. The ledger would have pages missing, and the universe would tolerate a kind of forgetting that quantum rules elsewhere do not allow. Later work suggested gentler endings. One idea is that a black hole's horizon is not an indifferent curtain but a kind of storing surface, a two-dimensional ledger that writes down the details of everything that falls in. From far away, the information could be encoded on that surface and then released, slowly, within the faint radiation as subtle correlations, too delicate for early calculations to notice, yet present in principle. This picture is called holographic because it treats a surface as carrying the content of a volume, the way a hologram can hold a three-dimensional image on a thin sheet. Another possibility is more adventurous. The information is not destroyed, but continues in a baby universe, a branching pocket that separates from our own. To us, the book would look incomplete. From the perspective of a larger library, nothing would be missing. In all of these sketches, the paradox softens without breaking the rules that keep physics coherent. However you prefer to imagine it stored on a horizon's skin, woven into the outgoing glow, or carried into a branch we cannot visit, the shared lesson is kind. A black hole is formidable, but it is not a delete key for reality. It rearranges, scrambles, and hides, and for any practical human purpose that may be indistinguishable from loss. Yet, at the level where laws must hold, the world seems to cherish its own continuity. Return, then, to the quieter pieces of the tale. A black hole near our sun would treat the star like yarn, not a single bite. The light we receive would flicker and harden before it faded, and the Earth would feel both radiation and tides. The rest of the system would buckle and seek new shapes. These images are sober, and yet they sit far away from us in the ledger of likelihoods. The giants we name in catalogues live at vast distances. The few black holes that drift near enough to weigh have been weighed precisely because they are quiet. The smaller engines we meet through their partners are, for the most part, content to keep their business with a single star. Between threat and theory there is also craft. People build machines that listen for the small tremors of space-time when heavy objects merge. They keep time so precisely that a variation smaller than a whisper stands out. They cool detectors until they are almost as quiet as deep space. They argue gently over graphs where a curve might be nothing, or might be a new thing discovered. Each of these efforts stitches comfort into the story, not because they promise rescue, but because they show how much of the universe can be known without panic. If the mind wants a final drift tonight, let it follow the thread of information back to the simplest image. A person near a horizon would still feel space as three-dimensional and time as a steady beat. Someone watching from far away would see the person stretch and slow, light reddening as it climbs out. Both views can be true in their own frames. The outside view might even be the one that keeps the ledger, writing a two-dimensional summary of a life that, inside, feels deep and full. It is a humble way to believe that the universe tells no lies, even when its stories are told in different voices. So the circle of night in the mind is no longer only a threat. It is also a promise that somewhere, even in the most extreme places, the rules do not forget themselves. A black hole can unmake a star and still fail to unmake the information that once flickered in that star's heart. The ring that flares when matter falls is violent, but it is also a light by which we read. And the distances remain generous. Far away, a particle is falling right now, adding a faint measure of heat to a disk we will never see with our eyes. Nearby, someone is closing a notebook because the small bump in the data turned out to be the hum of the building's lights. Nothing more. Here, the porch is still. The small star above it keeps its steady warmth. The circle at the center of the story stays where it belongs, a patient shape in the mind, not a shadow on the lawn. The porch, the small star, the quiet yard keep their shape, while another thought slips in beside them. Black holes have a reputation for being cosmic vacuum cleaners, prowling the dark and swallowing anything that wanders close. The truth is less frantic and more precise. They do not sweep the universe like hungry mouths. Their pull is like a cliff's edge hidden in night. Outside the border, you are fine. Cross it, and every path tilts inward. That border has a name that sounds almost ceremonial. The event horizon is the shoreline where escape would require light's own speed. Nature does not offer that speed to anything with mass. So once you step past the line, you are committed to the inward road. Before that line, gravity can be fierce and still negotiable. After it, no turning back. It is not a monster's appetite so much as the geometry of space-time keeping its rules. If some unlucky drift ever carried you towards such a shore, the end would not be a sudden crush, it would be a lengthening. The pull on your feet would differ from the pull on your head. Body becomes strand. The word is playful and exact at once. Spaghettification. In small, compact black holes, the stretching begins well before the horizon. In the gentler gradient near supermassive ones, you might pass the line intact and only then feel the tide take hold. Molecules separate. Bonds fail. It is not a violence you would feel for long. Yet even a place that allows no return can give something back to the wider world. Near the horizon, quantum fields flicker. Pairs of particles appear and part. A trickle of radiation slips away. A faint glow that slowly drains the black hole's mass. This is Hawking's insight. Given inconceivable spans of time, a black hole can evaporate. The effect is unimaginably weak for large holes, far beyond any human waiting, and the particles that leave carry no recipe for reassembling the things that fell in. Comeback is a poet's word here, not a plan. Still, it is comforting that even the darkest engines are not perfectly silent forever. Black holes themselves come in kinds that are simple to hold in mind. The common ones are the stellar remnants, born when very massive stars run out of fuel and collapse. They are tiny by cosmic standards, city-sized, yet carry the mass of many suns. The giants dwell in galactic hearts. Supermassive black holes gather millions and billions of suns worth of mass behind horizons on the scale of a solar system. Astronomers sometimes speak, with a wink, of stupendously large black holes, when estimates climb toward 100 billion suns, as in the heavyweight candidate at the center of the Phoenix cluster. Another famous beacon goes by a catalog name, TON 618, its glow reaching us from a younger universe, its mass tallied in tens of billions of suns. How such behemoths grew so quickly remains an open, lively question, and the full script of what happens when two collide is still being written in data and models. What we do know is steady. When heavy objects merge, they send ripples through space-time. We have begun to hear those waves. If black holes hide their centers, they do not hide their company. A black hole tugs the stars near it into unusual orbits. Gas that falls inward heats until it shines in X-rays. Jets sometimes lance outward along magnetic fields, bright signposts that mark a feeding engine. Even when the circle itself is invisible, its influence leaves clear signatures on its neighborhood. We read those signatures the way sailors read currents, indirectly and with confidence earned over time. The question that returns late at night is the one that does not need to be answered to be valuable. What lies beyond the horizon, if beyond even fits? Some equations admit an elegant bridge, an Einstein-Rosen connection that links one region of space-time to another. In stories, this becomes a tunnel, a passage to elsewhere or elsewhen. In the sober light of calculation, such bridges are fragile. They pinch off as soon as anything tries to cross. Holding one open would require forms of energy that push outward against gravity in a way ordinary matter cannot sustain. And even then, the tides and radiation near the throat would make a traveler's survival unlikely. The picture is worth keeping not because it offers a ticket, but because it shows how the same laws that shape our tides and sunsets also permit wild, symmetric possibilities on paper. So the reputation softens. Black holes are not sweeping the aisles of the cosmos. They sit where gravity has gathered them. They grow when something comes close enough to fall. They bend light and slow clocks and make rings of fire when gas spirals down. Outside the horizon, space is still space. Orbits still work. A planet can circle a black hole at a safe distance the way a planet circles a star, provided warmth is found by other means. At the edge, the rules grow stern. Inside, the story is finished from our point of view, though not from the universe's, which keeps its books carefully, even when we cannot see the entries. There is also the human scale to honor. The words we use belong to kitchens and front porches, because that is where most listening happens. Spaghettification is not a punchline when held against the night. It is a way to picture a difference in pull that would be otherwise abstract. Event horizon sounds grand, but it can be held as a simple threshold. Hawking radiation is not a glow we can touch. It is a promise that nothing in nature is entirely without give and take. Ton 618 and the Phoenix Giant are not threats on a calendar. They are distant furnaces that teach us scale. If two supermassive black holes do share a dance floor, the steps are slow. They scatter stars, stir gas, and gradually spiral together. In the last breath of their union, they send waves across the universe, and our detectors ring with that note. We have already heard smaller choirs, pairs of stellar black holes and neutron stars singing in higher keys. The background hum that radio astronomers now begin to sense may be the baseline of many supermassive pairs, all whispering at once. It is a comforting sound, not because it is gentle, but because it means the universe is legible at scales that once felt only mythic. Perhaps the most tender correction to the vacuum cleaner myth is this: you can orbit a black hole and never cross its edge. Gravity does not insist on doom, it insists on honesty. Stay outside the line and you remain a traveler, not a meal. Cross it and no traveler returns to report. In that sense, the fear and the fascination share a root. Here is a place where the map ends and the sea begins. Not with monsters, but with rules drawn so strongly that they feel like mystery. If the mind still wants a last image to carry back to the porch, choose one that breathes. A small world circling a quiet black hole far from any disk of falling fire, warmed by something ordinary and kind. Perhaps a nearby star, perhaps its own deep heat. Above that world, a ring of starlight arcs and bends the way a straw looks bent in a glass of water. Time runs a little differently there, nothing dramatic, just a gentle drift that good clocks can measure. Somewhere else a quasar rages, brilliant as 1,000 galaxies, and the light from its feast will cross intergalactic night for billions of years to reach new eyes. Somewhere nearer, a telescope turns away from a candidate black hole because the wobble in a star's motion was only the whisper of an unusual pair of suns. And here, very near, the small star above a familiar yard keeps its steady warmth. The circle that began as a threat and matured into a patient idea returns to its place. Not above the lawn, but inside the mind, where it can be admired without dread. The universe holds its fiercest engines at distances wide enough to sleep under. The rules that govern those engines are the same rules that let glass sing when you run a wet finger along its rim and let a pendulum keep time. Knowing this is a kind of rest all its own. The ring around the circle brightens in imagination, then dims, then brightens again, and nothing needs to be hurried. The small star above the yard keeps its steady warmth, while the mind, unhurried, turns a new page. If the darkest engines of the cosmos can unmake a star without unmaking the rules, what happens when one of the brightest lights meets one of the deepest wells? Picture a brief, needle-fine flash, pure energy, poured into a narrow beam sweeping across the night until it brushes a circle where every path falls inward. The thought is bold, but it can be held gently. Start with the well. A black hole is not different from other masses because it wants more. It is different because space-time curves so steeply near it that there's a boundary where outward stops being an option. That boundary, the event horizon, is simply the place where getting away would require light's own pace, and nature will not grant that speed to anything with mass. Outside the line, orbits and flybys follow the same clean rules as they do around stars. Cross the line and the road in front of you is made entirely of toward. Now, light. A gamma-ray burst is a lightning stroke, writ on cosmic scales, a narrow jet that can, for a few seconds, outshine entire galaxies. Some of these flashes come from the last breath of a massive star collapsing into a new black hole. Others are the aftershocks of two neutron stars spiraling together and collapsing into one. They happen somewhere in the sky almost daily. For an instant, or for half a minute, a beam of fierce light sweeps past, and then the darkness behind it closes again, as if someone drew a finger across water. These two, the well and the beam, already know each other. The birth cry of some black holes is a gamma-ray burst. And over long distances, random alignments guarantee that a few gamma-ray photons will pass near other black holes in their travels. If a burst grazes a black hole, gravity bends its path. If it aims straight at the circle, those photons do not return. To us, there would be no fireworks, as light and gravity collide. Light would curve as it always does. The black hole would remain a circle that gives nothing back from within its edge. No ripping of space-time, no switch that flips time into reverse, only the quiet certainty of geometry at work. For us, the drama is in the act of seeing. Human eyes are tuned to warm lamplight, not gamma rays. So a gamma ray burst would be invisible without instruments, even if it blazed 1,000,000 trillion times brighter than the sun for a heartbeat. The vacuum between stars carries no sound either. There would be no thunderclap to go with the flash. Scientists sometimes translate the changing energy of a burst into music, piano and cello singing where ears cannot, so you can hear a shape of the light without insisting that space itself make noise. Up close, there is nothing charming about such a beam. Gamma rays pass through metal and stone that would stop ordinary light. In a body, they break bonds and scramble instructions. Nausea, bleeding, stripped hair, damaged DNA. The list is short and final. If a burst were near, the wise response would be distance. And in most of the universe, distance is generous. Now, about that whisper, you may have heard stories of bursts replaying themselves backward, as if a clock had been turned. Observers have seen pulses with mirrored patterns, echoes that look like time reversed. It is a trick of perspective and physics, not of fate. When the source and its jets move close to light's pace, and the medium between us and the source slows and scatters different parts of the signal by different amounts. What reaches our detectors can carry a kind of visual palindrome. Nothing outruns light in a vacuum. Nothing rewrites the order of cause and effect. What looks like a backward step is a reflection in a tilted mirror, not a path that runs against the river. If a gamma ray burst skimmed a black hole, the two would not cancel one another or turn the clock. The hole would bend or swallow depending on the aim. The burst would either continue on a deflected path or be lost to the circle. If the burst happened to be the birth cry of the very hole in question, we would see the jet if it pointed our way, and if not, we would read the story in radio, afterglow, and in the trembling of space-time. If the event also sent out gravitational waves, the universe often provides multiple ways to learn the same lesson. From this small duet, let the thought drift wider to the biggest outbursts we have ever found. Sometimes a black hole at the center of a galaxy feeds quickly, and the energy released by the infalling gas pushes on everything around it. In one cluster of galaxies, astronomers traced a cavity in the thin, hot gas between galaxies so vast that you could lay many Milky Ways across it, side by side. It wasn't a black hole exploding. Black holes do not detonate like stars. It was a long, forceful breath from matter falling inward, a blast powered by gravity's bookkeeping, potential energy in, heat, and jets out. The outburst lasted for tens of millions of years and then relaxed, the way storms do. Counts and catalogs multiply, and they are best handled softly at this hour. The Milky Way likely hosts hundreds of millions of stellar mass black holes, quiet as stones unless a companion star brushes too close. Nearly every large galaxy appears to keep a supermassive black hole in its heart, from a few million to many billions of suns in mass. Some carry tidy accretion disks and slender jets, pencils of near light-speed matter guided by magnetic fields. Most are dormant. All obey the same grammar. What if, against character, every black hole acted at once, every quiet heart flared, every disk shouted, every jet fired? The picture is loud and instructive. Galaxies would brighten in fits. Gas would be pushed out of some centers and cooled into stars in others. The thin webs that link galaxy clusters would ring with shock waves. For places close to a feast, radiation would make harsh weather. Yet even in this wild imagining, there is no single boom that erases everything. Black holes can power storms that rearrange their neighborhoods. They are not fuses waiting to erase the universe. On the deepest ledger, energy and information change form and place. They do not vanish. The laws that kept their promises around the porch still keep them in the heart of a cluster. Let the scales settle back. Closer to home, a black hole wandering inward would announce itself long before it could do more than tug at our system's distant ice. Comets would take the hint and bloom tails more often. The outer planets would grow ragged first. We would never wake one morning to find a circle of night where the sun used to be. There would be a long preface of signs, and the distances between stars would continue to do their quiet, patient work on our behalf. As for time, if any story here tempts you to imagine stepping outside its flow, remember the comfort from earlier. Time can slow in motion and in gravity. It can be sliced differently by different observers. It does not turn back on command. A burst can seem to play in reverse because of how light and matter move and scatter. A clock can tick more slowly on a fast ship or deep in a gravitational well. Neither offers an escape from before to after. The arrow keeps its direction even when it curves. It is pleasant, even at midnight, to admit how much we do not yet know with a smile rather than a frown. How the largest black holes grew so quickly. How often the biggest pairs meet and sing their bass notes together. Whether any white hole-like coda ever follows a long evaporation. Whether some bridges on paper can ever be stabilized in practice by forms of energy we only glimpse in equations. These are morning questions, the kind that give researchers reasons to keep careful notebooks and carry coffee to quiet instruments. For tonight, the ring around the circle can return to its softer role. Somewhere, a burst has already flared and gone. Somewhere else, a central engine has paused between meals. Here, the small star over the yard keeps its honest warmth, and clocks keep friendly time. If a narrow beam ever crossed a black circle on the far side of the universe, geometry would guide it, as geometry always does. If a storm like the one in that distant cluster ever breathes again, it will shape its home and leave the wider sky untouched. The mind can hold both the fierceness and the order without strain. So breathe in the quiet architecture behind all the spectacle, paths that bend cleanly, thresholds that mean what they say, light that can be translated into music when ears are blind to it, and rules that remain themselves from porch to quasar. The circle of night in the mind brightens, dims, and brightens again, not as a threat, but as a steady invitation to wonder that knows how to let you rest. The small star above the yard keeps its faithful warmth, and yet the mind, relaxed and curious, can widen the frame. Far away in the same spiral we call home, imagine a narrow beam aligning with our lane, a jet from the quiet heart of the Milky Way, Sagittarius A*, turning active and pointing, by ill luck, our way. In that picture, superheated particles and hard light X-rays and gamma rays sweep outward like a lighthouse with no comfort in its beam. Such radiation would gnaw at the sky's shielding, thinning ozone in months until ultraviolet reached the ground unsoftened. The world would not scorch in an instant, but the sunburned chemistry of air and ocean would shift. Crops would suffer, skins would bite back, sleep would grow shallow under a harsher blue. This is a what-if held at arm's length, not a forecast, yet the choreography is simple enough to follow. Another imagined flare comes from a nearer name that astronomers once debated, a candidate black hole in a star system called HR 6819. If a burst rode outward from there, its fiercest photons would need centuries, something like 1,000 years, to arrive. Long before any local harm, the sky would sprout new, crisp points, strange brightenings that telescopes would register and catalog. The light would be history when it reached us, and in the long pause between sight and touch, we would have time to understand, to adapt, to turn away if turning were possible. Cataclysms of this kind do not erase a universe. They rearrange neighborhoods. Gas heated and flung outward can later cool. Shock fronts seed clouds. New stars simmer to life. Planets condense. The old violence becomes a future nursery. Even endings in space are often beginnings written in a slower tense. Time itself plays its old quiet trick near horizons. To a distant watcher, anything approaching a black hole's edge seems to linger, as if caught in syrup, clocks crawling toward a standstill, changes drawn out to an apparent eternity. Closer to the interior, near the border of that mathematical center, where our equations falter, an object can seem to hover forever. It is only the view from far away. For the falling traveler, moments pass in order. The crossing is ordinary until it isn't. Then the center arrives. Two perspectives, both honest, tell the same tale differently. From these far pictures, the mind can amble back towards something homelier, and still immense. A meeting in our own yard of planets. Not the Sun, not the whole system, but Jupiter, the fifth lantern from the star, swollen with storms facing a compact intruder. Hold the match as a gentle exercise rather than a drumroll. Jupiter orbits roughly 500 million miles from the Sun, a great, banded globe more massive than all the other planets combined, an anchor that shapes the rhythm of our small neighborhood. Across from it in this thought stands a black hole of the stellar kind, born from the death of a giant star, small across, but dense beyond imagining. A 10 solar mass black hole could be only dozens of miles wide and yet weigh 10 suns. The scale is unnerving because density does the work here, not size. We move through the galaxy with real speed, our star and its family sailing through space faster than numbers feel on the tongue. And once in a very long while, another star can pass close enough to stir the outer dark. The chance is slim. The nearest star is still many light years away. Some estimates speak of only a % chance of a truly disruptive flyby over great stretches of time. Rarer still would be a wandering black hole straying near Jupiter. But suppose the unlikely visit unfolds, slowly enough to watch, quickly enough to change the map. The first rumor of trouble would rise from the far cold, the Oort cloud, a dim, spherical fog of icy debris, stretching almost 2 light years from the Sunday. A passing gravity well would pluck at that fog, sending long trains of comets inward. The Kuiper Belt, a nearer ring beyond Neptune threaded with ice, dwarf planets, and rock, would also feel the tug. Some bodies there, Pluto among them, could be nudged from their quiet courses. What begins as a distant adjustment becomes a spray of potential impacts heading sunward. For a time, summer night skies would carry more visitors with tails. The intruder's path toward the planets would write a calm script with cruel results. Gas giants would feel the pull first. Neptune's and Uranus's outer layers would fray. Delicate curls of hydrogen and methane would rise and stream away. Saturn's gauzy rings would distort and then loosen into ropes of particles feeding a new, hot ribbon around the black hole. As the visitor passed close to each planet, tidal forces could alter orbits enough to eject a world or lock it into a new, uncertain path. Jupiter, richest in fuel, would meet the sharpest hunger. Hydrogen and helium would lift from its topmost bands in long, luminous threads, like yarn pulled from a patient skein. Those threads would feed a disk that brightens by friction and fields as it spirals inward. The disk would make the otherwise invisible visitor visible at last, a ring of furious light with a circle of night at the center. After a while, the planet would not be a planet. It would be an event in the disk, a heaping portion briefly bright and then gone. Such feeding is not silent in the invisible parts of the spectrum. As the disk thickens and heats, it can fling bursts of ultraviolet and X-rays outward in quick, hard flashes. For a world like ours, that radiation would arrive in less than an hour after it is made, riding the emptiness at light's pace. The atmosphere would take the first blow, chemistry changing at high altitudes, protections thinning, electronic senses would complain, birds and beetles would lose the sky's subtle cues. It would be an unfair contest, and a brief one, and no visor or visor word would make it gentle. With Jupiter gone, the solar system, if spared a direct swallow, would need to find a new balance. Our large neighbor has always served as a polite bully, shepherding bands of rock and ice, swallowing many would-be threats, and keeping the inner lanes calmer than they might otherwise be. Without that anchor, The asteroid belt would be a different choir. Some orbits would lengthen and cross. Comets that once missed might not. Earth's nearly circular path could grow slightly eccentric under the slow tug of altered masses and distant encounters. And small differences accumulated over ages would mark coastlines and calendars with new patterns of freeze and thaw. All of this is an exercise held softly in the hand, respectful of scale and probability. The chances are low, the distances are generous, the sky is not a hot highway of accidents. We hold the story to learn the shapes of the forces, not to borrow unnecessary fear. If a rogue black hole came, there would be heralds, comet showers years ahead, shifts in the outer planets, a brightening where a dark visitor fed. If nothing comes, the lesson remains. Gravity does its work in patient spirals. Disks shine, not because night grows hungry, but because falling matter pays its energy as light on the way down. And even here, where the tale turns stern, the old comfort returns. A jet from the galactic center aimed at us is a thought experiment. The real Sagittarius A Times is a quiet neighbor today. A candidate flare from a nearer system would give us centuries of notice. Outbursts that hollow clusters do not erase the universe, they sculpt it. Lifting gas that later cools into the next generation of stars. Time near horizons remains a matter of viewpoint. Clocks are honest on every path. The same rules that let a crystal form from cooling atoms, let a ring of fire appear around a dark circle. The same rules that shape a lullaby on a porch, shape a jet 10 billion light years away. So the mind can set the pieces down where they were found. Far outside, some burst has already spent itself, its afterglow fading into the quiet between galaxies. Not far from here, Jupiter continues its slow, stately turn, banded and bright, doing the steady work of a guardian no one hired. Comets keep to their deep orbits, mostly. The Oort cloud remains fog, not a storm. And here, in the near dark, the small star still warms the yard. The circle at the center of our long story brightens, dims, and brightens again. No longer a threat, not a promise of miracles, but a clear, calm shape the mind can admire before sleep. With the calm picture settled in the mind, another curiosity drifts in, soft as a moth at the window. Suppose a heavy star finishes its bright work and folds in on itself until a black hole is born. Suppose, too, a patient traveler wonders what waits beyond the dark circle. Going in is not a plan, because stories that cross the horizon do not return. So the gentler question is the better one for tonight. Is there a way to look across a black hole without ever touching its edge? What does light do near such a place? And did that first fuzzy portrait of a black hole already whisper more than we first heard? Sight is only ever a conversation with light. If an object neither shines on its own nor throws light back toward us, eyes alone will not find it. A black hole seems like the perfect hiding place, because it does not emit light from within, and it gathers almost all that wanders too close. Yet space-time around it has a habit that turns darkness into a mirror of sorts. Gravity bends the paths of photons, and near a black hole, that bending becomes a slow, graceful whirl. Think of the first picture humanity stitched together of such a whirl. Radio dishes scattered on mountaintops around the world linked arms to act like one Earth-sized lens. The result was not a high-resolution postcard, more a candle flame seen through fog, and still, it carried the essential shape, a bright, uneven ring hugging a circular shadow. Look closely at that ring, and you are already, in a quiet way, seeing light from the far side. The delicate, thin lane within the glow, is sometimes called the photon ring or photon orbit. It is made of photons that have looped around the black hole 2 or 3 times, sometimes more, before escaping toward us. They are not ghosts. They are ordinary light particles that took the scenic route. Here is a picture you can hold without numbers. Place a star behind a black hole from our point of view. The star sends light in every direction. The rays that would have come straight to us are swallowed, erased from our view by the hidden edge. But some rays that would have missed us entirely are bent by the black hole's pull, coaxed into curved tracks. A few swing most of the way around the circle and then slant outward toward Earth. To our eyes, they appear to come from a bright rim, yet their journey began behind the dark center. Gravity has turned a barrier into a lens. What we call the shadow is not the black hole itself. It is the footprint of paths that did not return. The ring around it is a map of the photon paths that did. This is not quite the same as peeking inside. The horizon remains a true line. Steps beyond it point only inward. Light that crosses that border does not return to tell us what it found. All the seeing from outside is the work of bending, not of crossing. Still, much is written in that ring. Its brightness tells us how matter heats as it spirals down. Its shape and slight off-center glow hint at spin, because a rotating black hole drags space-time around with it, making one side of the ring look a little bolder than the other. Later portraits, taken with light remembered in its polarization, even sketch the direction of magnetic fields near the edge, threads that help shape the flow. If a traveler ignored wisdom and went in to look, the view would not match the fictions. The first part would feel almost ordinary for longer than seems fair. Infall can be slow when you are far away. As the horizon nears, the sky behind would appear to crowd into a shrinking circle, and the forward view would widen until everywhere seems forward. Cross the line and you could still see, because you would still be there with the light that fell in. But directions would lose their familiar meaning. Photons would arrive from odd angles, as if the room had been folded. Look away from the center, and there might be a uniform glow from light that is bounced and bent within. Look toward the mathematical heart, and there would be only dark, not because there is nothing, but because our equations run out of breath trying to describe it. None of this would be something you could report. Inside is a private experience. Outside is where measurements can be shared. There is a milder way to deepen the view from outside. When a black hole sits in front of a messy background of gas and dust and bright knots, its gravity can paint the scene into multiple images, stacked and intertwined. Astronomers call the elegant version of this an Einstein ring when the alignment is exact. More often, it is a warped arc here, a stretched dot there, a smear that looks like a crescent. Each piece carries information about the mass and spin of the black hole and the shape of the stuff around it. Add many pieces together across many nights, and a portrait emerges that is more map than picture. None of this changes the rule at the heart of the story. A horizon is still a firm threshold. What crosses it keeps going in. What stays outside can circle and return and be read. That is enough to answer the gentle version of the old question. We cannot see through a black hole as a window. We can see around it, and strangely, the light from behind can be coaxed into our eyes by the very gravity that would otherwise hide it. The first image of a black hole did not reveal a doorway. It revealed a mirror with a curved frame. Let that idea breathe, and then follow it a step farther, because the ring in that portrait holds more subtle layers than the eye can separate in one look. Photons that loop once, twice, thrice, each add a thinner and thinner subring inside the glow, a set of nested halos. In principle, they carry almost a barcode of the space-time near the edge. With sharper instruments and patient algorithms, future images can peel those layers apart, the way a musician hears harmonics inside a single note. Each layer refines the measure of mass, the measure of spin, the way the flow of matter flips and corkscrews before it disappears from view. You might ask, gently, whether this means we can ever learn what happens to the stories that fall in, not the atoms, which keep their modest identities only so far, but the deeper patterns, the information that described them. From far away, the best answer remains faithful to the theme of the night. The universe keeps its books, even when we cannot page through them. The horizon may store a kind of ledger on its surface. The faint glow that leaks away over eons may carry subtle hints in its correlations, or the accounting may be written in a larger library we cannot visit. In all the versions that respect the rules, nothing is truly deleted. It is scrambled and hidden past usefulness for us, and yet not lost to the deeper order. If you turn back now to the idea of a special telescope, so large it circles the Earth in radio dishes rather than mirrors, you can see how far patience has already carried us. The first portrait was a beginning. More dishes are joining the chorus. The wavelengths can be tuned. The algorithms can be sharpened like knives honed on quiet mornings. Someday the images will show that photon ring with finer lace. Someday we will watch flares flicker as clumps of gas whirl and vanish. Someday the same network will freeze the wobble of a silhouette as two black holes spiral toward a union, the shadow's shape nodding to the slow drumbeat of gravitational waves. All of this keeps to the mood that lets sleep arrive. There is drama in the cosmos, yet it is not a theater of jump scares. Even when we talk about falling in or seeing around corners by bending light, the story runs on rules we can learn to trust. The circle in the image marks a boundary that keeps its promise. The ring around it is the patient sum of many long paths. Light from behind becomes light for us, because gravity guides it so. A telescope the size of a planet becomes possible because timing and teamwork can weave a single eye from many small ones spread under different skies. If you need one last picture to rest on, choose this. A black hole sits far away in a messy neighborhood of glowing gas. Behind it, stars keep their own counsel. A thin, bright ring is braided from photons that have gone the long way around. Some of that light began behind the circle. Some began beside it. All of it was bent into a loop by a geometry we have learned to name. No one had to plunge past the edge to see it. No one had to return from a place that gives no returns. We listened with dishes on mountains, compared whispers recorded in different nights, and found a shape that matches the story our best equations tell. The yard is still warm. The little star above it has not changed its mind. Somewhere, another array of dishes is turning toward another dark center. Somewhere else, a graduate student is coaxing a faint ring from stubborn data and smiling as the curve closes. Here, the ring in your thoughts brightens once more and then softens. The circle at its center stays quiet and exact. The mind is allowed to drift, because even in the dark, the rules that carry light to the eye are kind. Hold the picture for one more breath. A quiet yard, a steady star, and far away a thin ring of light gathered by patient dishes and careful minds. Somewhere a screen still glows with a closing curve. Somewhere a notebook carries a small check mark, and here the circle in your thoughts softens until it is only warmth. We walked a gentle arc tonight. We let gravity be a way of telling truth, not a threat. We stood outside horizons and watched light take the long way home. We kept company with photon rings and quiet jets, with clocks that slow in deep wells, with tides that stretch, and with rules that stay honest, even where the dark grows deep. We listened to the idea that nothing real is truly lost, only rearranged, and that the universe keeps its ledger with care. We let monsters become methods, and we let distance be a kind of safety. The larger lesson is simple enough to rest on. The same laws that guide a porch light across a wall also shape a quasar's blaze. The same patience that tunes a telescope teaches a mind to drift. The sky is full of fierce engines, yet it is also generous with space, with time, with room to breathe. If a question lingers, let it linger. Let it travel among the stars that keep their roots, among the rings that brighten and fade, among the instruments that will still be listening in the morning. You do not have to finish the thought. You can let it keep going without you. Close the door a little on the world. Let the last of the day loosen. The circle grows dim, the ring fades to a hush, and the quiet that remains is yours. Sleep can take over the telling now, turning pages in the dark while you rest. When you wake, the rules will still be kind, the small star will still be warm, and the story will still be waiting, unhurried, wherever you choose to pick it up again.